The ground is rumbling beneath the Pacific Ocean, magma has been discovered beneath Central Europe, and a giant slumbers in the Mediterranean that could erupt at any moment. At the same time, researchers are detecting cracks in the Phlegraean fields. What's happening to our planet right now? We're taking a close look at it today and diving right in. The World Cup is currently underway in North America, but there's something that could dampen the World Cup spirit. Researchers are actually quite certain that a massive underwater volcano off the coast of the US will erupt in the very near future. If you're as fascinated by volcanoes as I am, why not subscribe to the channel right now? It's just one click for you, but it helps me out a lot. If you've already subscribed, please support the channel with a like. Thank you so much, everyone. There are approximately 1,350 potentially active volcanoes on Earth, and that doesn't even include the long volcanic chains on the ocean floor. About 500 of them have erupted since the beginning of recorded history, and almost always several volcanoes are erupting simultaneously somewhere in the world. A particularly large number of volcanoes are located along the Pacific Ring of Fire, where tectonic plates collide, subduct, and magma rises to the surface. But volcanic activity on Earth seems to be especially intense right now. This is also the case off the US West Coast, deep beneath the Pacific Ocean. For down there lies a volcano whose next eruption scientists might witness live for the first time in history. Axial Seamount is one of the most active underwater volcanoes in the entire North Pacific. This volcano is located about 480 kilometers off the coast of Oregon, roughly 1.5 kilometers below the water's surface, and is currently causing quite a stir. Last June, measuring instruments recorded a staggering 2,000 earthquakes in a single day. Axial Seamount lies on the Juan de Fuca Ridge, an active geological spreading zone. This is a location where two tectonic plates are drifting apart, constantly creating new seafloor. What makes Axial Seamount so special is its predictability. While most volcanoes are completely unpredictable and often catch scientists by surprise, this underwater giant follows a fairly clear pattern. Scientists can actually predict relatively accurately when this volcano will erupt by observing how the seafloor bulges. This happens because a magma chamber beneath the volcano fills with hot rock, pushing the seafloor upward. Researchers have determined that once the volcano has risen by about 25 centimeters, the next eruption is imminent. And now it gets exciting. The volcano has already reached this critical threshold, making it almost certain that it will erupt by the end of the year. But how do scientists actually monitor a volcano that lies 1.5 miles underwater? This is where the Ocean Observatories initiative comes in with a state-of-the-art cable network. Imagine hundreds of kilometers of fiber optic cable running across the seafloor, supplying dozens of monitoring stations with power and data transmission. These instruments measure earthquakes, ground deformation, temperature changes, and the chemical composition of the water around the clock. But what happens when the volcano actually erupts? There is likely no danger to people on the coast. The volcano is too far away and too deep underwater to cause direct damage. Nevertheless, an underwater volcanic eruption is a spectacular event. Hot magma shoots out of cracks and vents on the seafloor. The rock hits the cold water and solidifies immediately. At the same time, huge clouds of steam form from superheated seawater, and the seafloor can sink by several meters as the magma chamber empties. There is also no great danger to marine life. These are surprisingly resilient ecosystems. Although underwater volcanoes initially destroy local ecosystems, they simultaneously create new habitats. The hot hydrothermal vents that form after an eruption are oases of life in the deep sea. All indicators therefore suggest that the Axial Seamount has reached the critical threshold. The only question is, will it be a spectacular eruption like in 1998 or a moderate event like in 2015? Even the experts cannot say yet, but what we do know is that when it happens, scientists will be able to follow it live. For the first time in the history of volcanology, researchers can use this technology to observe an eruption from the very first moment in real time and understand exactly what is happening in the depths of the Earth. This will revolutionize our understanding of volcanoes. But there is rumbling beneath Europe as well. What is happening there has surprised even experienced volcanologists. Between September 2022 and August 2023, scientists at the Helmholtz Center for Geosciences conducted the largest seismic volcanic experiment ever carried out in Germany. Over 500 seismic monitoring stations were deployed across the Eifel region, more than ever before. In addition, a 64-kilometer-long fiber optic cable was installed, allowing researchers to listen to the Earth. This enabled them to locate more than 1,000 microquakes in the region within a single year. This means that the region is experiencing earthquakes 5 times more frequently than previously assumed. Most of these quakes occurred along a narrow vertical zone around Lake Lech. This is no ordinary lake, it lies in a volcanic crater, and the volcano's last eruption 13,000 years ago was violent. It was a highly explosive eruption that left behind massive deposits of ash and pyroclastic flows. The explosion was so massive that it is classified as a VEI6 eruption, the third highest level of volcanic activity. Currently, the volcano is merely dormant. It is by no means extinct. The new data reveals for the first time exactly where the magma reservoir is located. Seismic tomography, a kind of X-ray image of the subsurface, reveals a massive anomaly beneath Lake Lacher extending to a depth of 10 kilometers. This anomaly does not extend vertically downward, but slopes toward the Neuwied Basin, the very area where most microearthquakes cluster. Previously, it was thought that the ancient magma reservoir lay directly beneath the lake. In addition, magmatic fluids apparently rise repeatedly from the depths in the region. At a depth of 15 to 45 kilometers, there is a partially molten mantle zone. From there, hot gases and liquids make their way upward, and these fluids weaken the Earth's crust, redistribute tectonic stresses, and cause the many microseismic events. However, the scientists expressly emphasize individual microquakes are not an indication of an impending volcanic eruption. On the contrary, they help us better understand the processes underground. The Lacher Sea volcano is a geologically active system in a dormant state, but it is also not on the verge of erupting. But if you ever visit the area, you can even observe the volcanic activity firsthand. On the eastern shore of the lake, small gas bubbles, known as moffetts, rise to the surface. This is direct evidence of volcanic activity. Even though there is no immediate danger of an eruption right now, it will happen again at some point. Incidentally, the region is a perfect example of what are known as dispersed volcanic fields. These are volcanic areas where hundreds of volcanoes are spread out over a very large area. Each of these volcanoes is usually active only once. Afterward, volcanic activity shifts to another location. Such distributed volcanic fields also exist in other places, for example in Arizona, China, New Zealand, or in France's massive central, but the Eifel is special because compared to the other regions, it is more densely populated and thus well researched. Nowhere else have scientists established such a dense network of monitoring stations. The Large N experiment has made it possible to map the structures with unprecedented detail. However, no one currently knows exactly when another eruption can be expected. And that is why it is so important to continue monitoring and researching the region, and the Large N experiment was a giant step in the right direction toward a better understanding of this volcanic system. But let's move on to the Mediterranean. Hidden between the Italian mainland and Sicily lies one of Europe's largest volcanoes, and very few people have ever heard of it, Marsili. This giant was discovered only about 100 years ago, and at 70 kilometers long and 30 kilometers wide, is one of Europe's largest volcanoes. It rises about 3,000 meters from the seafloor, and its peak lies only about 500 meters below the water's surface. It is part of a geological structure that scientists call a back arc basin. Such basins form in subduction zones where one tectonic plate dives beneath another. Marsili's volcanic activity began less than 200,000 years ago. The most recent eruptions took place just 2,000 to 3,000 years ago. A study published in the journal Geoscience Frontiers used high-resolution bathymetry, a type of underwater topography, to examine Marsili's structure in detail. The volcano consists of several different volcanic structures. In the northern and southern regions, there are large central volcanoes, while long volcanic fissures dominate the central region. These fissures are particularly interesting because they show how magma rises from the depths. A finding in the northern region is particularly concerning. There, the researchers discovered a caldera, a cauldron-like collapse structure that forms when a magma chamber beneath a volcano collapses. This suggests that Marsili has experienced explosive eruptions in the past. And this is where things get critical. Enzo Boschi, the former president of the Italian Institute of Geophysics and Volcanology, explained as early as 2010 that the volcano is structurally unstable. But would an eruption at this depth even be felt at the surface? The answer is, it depends. Scientists assume that a purely volcanic eruption at this depth could be relatively harmless. The massive column of water would dampen the energy of the eruption. On the surface, one would mainly see gas bubbles rising. The real danger lies elsewhere, in massive underwater landslides. In their latest study, the researchers found that large sections of the Marsili flank consist of unstable material. Hydrothermal processes, that is, hot chemically aggressive fluids circulating through the rock, weaken the rock and make it porous. A 2021 study ran through various tsunami scenarios, and in the worst-case scenario, a landslide could cause the coasts of the regions of Campania, Basilicata, and Calabria to be hit by waves 5 to 20 meters high within 20 to 30 minutes. Sicily and Sardinia would also be affected, but, and this is important, this scenario is relatively unlikely. The study analyzed several scenarios, and in most cases the impacts would be significantly less severe. In some scenarios, wave heights of only a few centimeters would occur, posing virtually no danger. What does all this mean for the future? The biggest problem is that we know too little. The Marsili is not currently under continuous monitoring. There are no seismic sensors on the seafloor, no direct measurements of hydrothermal activity, and no real-time monitoring of potential changes. This is astonishing, considering that millions of people live near the coast who would be affected in an emergency. The good news? The probability of a major disaster is actually low. Although Marsili is active, geological processes generally proceed very slowly. A sudden disaster occurring without warning is unlikely. But to detect warning signs early enough at all, monitoring the volcano would of course make sense in some way. And by the way, the Marsili isn't the only underwater volcano in this area. There's also the Vavilov, the Magniagi, and the Palinuro. All are potentially active, and we are only just beginning to understand the processes taking place deep below. Let's stay in Italy for now, because the supervolcano in the Phlegraean fields has cracked. Does that make an eruption more likely? When this supervolcano erupted nearly 40,000 years ago, it buried half of Europe under a layer of ash. Remnants of that eruption were found as far away as Siberia and Egypt. Since then, there have only been minor eruptions. In about 1538, an eruption gave rise to Monte Nuovo, which today lies within the city limits of Pozzuoli. But since 2005, the volcano has become more active again, and the ground has risen by a total of 1.40 meters. At the same time, volcanic tremors are increasing steadily, most recently on June 13th with a magnitude of up to 4.6. The strongest quake ever recorded in the region. So as you can see, the situation is somewhat alarming. And now on top of that, the discovery of gigantic fissures beneath the Campi Flegrei. A team led by Giacomo Rapagnani from the University of Pisa has taken another very close look at the seismic data from recent years. And in doing so, they stumbled upon something that has never before been observed in the Campi Flegrei, very long period seismic signals, so-called VLP waves. What's special about these signals is that there are more than 2 seconds between the individual wave crests. That doesn't sound particularly spectacular at first, but it's a clear indication that there are structures underground that function like gigantic resonating chambers. Imagine you have a huge underground network of tubes through which gases and vapors flow upward from the depths. When this system is set into vibration by earthquakes, these characteristic long-period signals are generated, just like a gigantic organ pipe underground. Analysis has revealed that these mysterious structures are located at a depth of about 3.5 kilometers and run diagonally upward toward the surface. They connect the deep magma and gas reservoir with the gas vents near the surface in the city of Pozzuoli. Put simply, the researchers have discovered a direct gas channel from the supervolcano to the surface. This reveals just how stable this structure is. However, the resonance frequency has remained the same in recent years, which means that the overlying layer above the magma reservoir is still stable. At a depth of about 1.5 to 2 kilometers lies an impermeable layer of rock that sits like a lid on the magma reservoir. The gas and water vapor rising from the depths cannot pass through this barrier, causing pressure to build up continuously, and this also explains why the ground in the region has risen so dramatically. The newly discovered fissure system apparently functions as a kind of pressure relief valve. It allows gases to escape in a controlled manner without leading to a catastrophic buildup of pressure. The center of activity lies beneath the city of Pozzuoli, west of Naples. Here there is a crater about 700 meters wide that was formed during an eruption around 4,000 years ago. In this region, CO2 emissions rose from 750 to over 3,000 to 4,000 tons per day between 2000 and 2019. The Phlegraean fields are home to an incredible number of over 50 eruption sites. Incidentally, the technique the researchers used to make their discovery is quite impressive. They used what is known as moment tensor inversion. This involves analyzing the seismic waves recorded by various monitoring stations. From the minute differences in the arrival times and characteristics of these waves, the scientists can then draw conclusions about the structure beneath the surface. What the study also shows is just how complex volcanic systems really are. The Campi Flegrei are not simply a few craters with magma sloshing around somewhere beneath them, but a highly complex network of magma chambers, gas channels, and geological structures. The fissure system now discovered is likely just a small part of a much larger system. For the several million people in the Naples metropolitan area, the discovery is therefore highly relevant. Even though there is currently no immediate danger of an eruption, it does show that the supervolcano is anything but dormant. All these individual cases fit into a global pattern that has been occupying geoscientists for months. The Pacific Ring of Fire is exhibiting activity that is unprecedented in recorded history. Dozens of volcanoes erupting simultaneously, swarms of earthquakes along tectonic fault lines. Stretching about 40,000 kilometers in length and up to 500 kilometers in width, the Pacific Ring of Fire is a gigantic geological zone that encircles the Pacific Ocean like a giant horseshoe. Between 750 and 915 active and dormant volcanoes are located in this region. That is about 2/3 of all active volcanoes worldwide. About 90% of all global earthquakes occur right here. Why is that? The Ring of Fire is not a single geological structure, but was created by the subduction of various tectonic plates at the boundaries of the Pacific Ocean. Simply put, gigantic tectonic plates rub against each other, collide, and slide beneath one another. And this friction generates the raw energy that drives both earthquakes and volcanic eruptions. And the danger is that millions of people live in the immediate vicinity of these active volcanoes. On May 2nd, 2025, 47 volcanoes were simultaneously in an active eruptive state, one of the highest figures in recorded history. What is really giving geologists a headache is the clustering, the concentration of major eruptions within a very short period of time. This points to potentially interconnected geological processes. The volcanoes erupt almost simultaneously, with some even showing repeated episodes within weeks or days. Indonesia is at the epicenter of this volcanic awakening. The country recorded an incredible 6,508 volcanic eruptions in 2025. Several volcanoes were involved, including Semeru, Dokano, and Merapi. Mount Semeru in East Java topped the list with 2,500 eruptions. Mount Merapi, one of Indonesia's most dangerous volcanoes, also made headlines. On October 1st, 2025, researchers documented a pyroclastic flow that led to a 5-kilometer exclusion zone. The volcano is located directly above the densely populated island of Java. On July 29th of last year, an 8.8 magnitude earthquake struck off the coast of the Kamchatka Peninsula in Russia. The quake itself was already catastrophic, but what happened afterward was extraordinary. The Institute of Volcanology and Seismology of the Russian Academy of Sciences reported on August 6th that 7 Kamchatka volcanoes had erupted as a result of the earthquake, an event that had not been observed in this region for nearly 300 years. How do researchers keep track of everything amid all this chaos? The short answer: through a combination of ground-based sensors, satellite imagery, and volcanological observatories worldwide. Volcanic warnings are issued by scientists at volcanic observatories and are based on the analysis of data from monitoring networks, direct observations, and satellite sensors. The United States alone operates 5 regional volcano observatories, and similar facilities exist in Japan, Indonesia, Russia, and other countries along the Ring of Fire. These observatories track seismic tremors, ground deformation, gas emissions, and thermal anomalies. Satellite technology has further revolutionized volcano monitoring. Scientists can now detect subtle changes in volcanic heat signatures or ground swelling from space, often before a visible eruption occurs. This gives entire regions valuable time to evacuate. One of the warning signs scientists look for is what are known as seismic swarms, a cluster of small earthquakes occurring in rapid succession. Japan's seismic monitoring network detected an unprecedented pattern of earthquake swarms along the Nankai Trough. The Japan Meteorological Agency reported over 3,200 small to moderate earthquakes in the region during the first quarter of 2025, compared to just 800 the previous year. These swarms often indicate magma movements deep underground. When molten rock pushes upward, it fractures the surrounding rock and generates tremors. The more intense the swarm, the higher the likelihood of an imminent eruption. Scientists are now working feverishly to understand this. The entire Pacific Ring of Fire recorded over 15,000 earthquakes of magnitude 4.0 or higher in 2024 alone, a 23% increase. Each of these earthquakes can destabilize volcanic systems or trigger secondary hazards such as landslides and tsunamis. So while monitoring systems are working overtime to track these geological processes, the question remains, is this a temporary spike or the beginning of a longer-term tectonic crisis? To be honest, no one knows for sure yet. But I hope this overview has helped you better understand the connections. The Earth is not a silent, motionless rock in space. It lives, it breathes, it pushes outward from within, and we're right in the middle of it. Personally, I find that absolutely fascinating every single time. I'll of course keep you updated on all further developments here on the channel, but there's been even more exciting stuff happening in the world of science lately, and the craziest news revolves around Ötzi, the famous glacier mummy from the Alps. Frozen in ice for millennia, but now scientists have discovered something alive inside him, something that's actually still alive and thriving. You can find everything about this crazy story and lots of original footage of Ötzi in the video shown at the top right. Be sure to check it out, it's really fascinating. At the bottom right, there's another exciting topic about science and space. Otherwise, I'd say see you in the next video. Take care, everyone.